So where do I go and get the Google Hangout link?
So I just posted those to the Meetup, so it's in the comments.
All right. Just for fun, I'm going to follow on my iPad.
And it's on the Google Plus event page.
Oh, okay. Yep. I remember seeing
At least I thought I did. All right, so welcome to this month's GDG. First couple notes. If you haven't already, follow us or join the Reddit account. You can get to it either reddit.com/r/chawdev or chatdevs.com. I think still points. I know that's different. That's a different website. Yeah. So we also have ChawDev channel on Freenode and a calendar of events for the local Chattanooga area. A couple of quick things coming up. Next Dev Lunch is tomorrow at Society of Work. And this one is on net neutrality by a couple of the Mozilla guys. So it should be really interesting talk to go to. There's also Arduino nights, same day at 4 p.m., 4th floor of the library. Then we have CodeXX on the 23rd at 6 p.m. Then there is Map Time Chattanooga. Its next meeting is on the 24th, 5:30. No location as far as I'm aware of right now.
So the map meetup doesn't have a location?
It's 4th floor of the library.
Oh, okay. He had TBA on it.
I'm pretty sure it's going to be 4th floor of the library.
All right. Well, then that would also be sharing the room with the Bitcoin meetup.
Oh, is it the same day? Oh, I see.
Same day, just 30 minutes after on the 4th floor.
There's 2 spaces up there. Kind of.
Yeah. And then the Drupal user group got pushed back to being next week. There's also 3D printing classes going on at the library. Those will be, next one of those will be on the 1st at 5 and 5:30, 4th floor. There's also a Open Chattanooga and Mozilla Open Work Night, same night, 5:30. And PHP use is July 9th at 11:30. No location set on that yet. And Nougat.js, July 15th, 5:30, Society of Work again. And I don't think I missed anything this time. And with that, let's get on to the topic of today. Data types and structures in Go. So Go's type system, it's a strongly typed language, which means that all variable types have to be explicitly named, and you have to cast between data types. It doesn't assume any of that. Uses structures and interfaces for advanced types, and there's also no generics, but that doesn't have to be a bad thing either. A quick rundown of Go's built-in type systems. There is several ints. You have the ints without a size is architecture dependent. So on a ARM, it will be a int 16. On a 32-bit system, it's the same as an int 32. And on a 64-bit, it's the same as a int 64. uints work the same way. The normal uint is architecture dependent, and then you have a float 32 and float 64, and then the complex works just like a float, except they also have support for imaginary numbers, making them ideal for scientific computing and other practices. And then other non-numeric types, you have a Boolean, a byte, which is basically an alias for uint 8. You have a rune, which is an alias for int 32, and those are used to store Unicode characters. It has a built-in string type, a unsigned integer pointer type, which that goes along with the complex types, good for scientific computing. You're probably not going to touch it anywhere else. And then error is a data type, but that comes in handy because they have methods defined on that. There's two ways to declare variables in Go. There's an explicit way, which you also get to name or specify the data type during the defining, and there's a shorthand which uses the compiler's defaults. And so using the longhand, you start off with var, variable name, and then you give it the type. And you can do multiple assignments at once. So if you're going to define two ints, you can do it this way, where it's var, your variable's data type, and then it assigns it in the order that they're in. So in this case, I would be 1 and j would be 2. And then the shorthand works the same way, but the notation for that is colon equals. And those use the compiler default. So if it's a number, it'll be a int or a uint versus being able to say that this is a int 8. But those also get also are able to do multiple assignments. And you don't necessarily have to have the same data types using the shorthands. So in this case here, we have a variable of C, variable of Python, a variable of Java, and a num. Well, C and Python are going to be Boolean. Java is going to be a string, and num is going to be an int. It's able to work those differences out using that method. And when a variable is declared but not initialized, it has what's called the nil value. So for number types, that would be 0. For a string, it's an empty string. Boolean, it's false. And everything else is nil. And so here is a little quick example. We have 3 variables, S1, S2, and S3. And we have hello world in English for the first one. The second is hello world in Hindi, because no one ever uses Hindi as examples. And the last one is the Apple flower key. And we can see what types they are. If you're familiar with the way sprintf works, you pretty much know how to drive sprintf in Go. So in this case, the %T, it will actually spit out the data type of that variable. So if we click the run, we see that S1 and S2 are both strings, whereas S3 is an int32 since it was a Unicode rune. The way type conversions work is you cast it using the type and then the data that you want to cast in parens. So in this case, we are defining a integer of 42, and then we're going to convert it to a float 64, and then convert it to a unsigned int. For that, we have to specify that it's going to be a float 64 and a uint. Using longhands, that gets redundant because on both sides you have the data type, but the reason they did that is when you're using the shorthand assignments, it actually makes it clear what's going on. And unlike in C, Go assignments between items of different types require explicit conversions. So if we were to remove float 64 or the uint, it would fail due to a compile error of type mismatch.
So, but wait a second. In there it would? Why would it do it there? Because there you're letting the compiler define it, right?
Because if we were to take this out, then we're no longer typecasting. So it would be trying to take that. This f would be this one here, that would be an int. But if we were to do it up here, that would be a type mismatch, because we'd have an integer going into a float 64.
Right. That's not. Yeah. That's
Yeah,
what
so
I was saying. So here.
In this case, it would work. It would just be an integer.
Be another copy of it.
Yeah.
Or a pointer to it, or whatever.
Yeah, this one would work. The first
So the reason
case.
why that makes sense to me is that you're basically calling a class constructor with an argument.
Basically, yeah.
And that makes sense to me, but Python, so.
Yeah, and a lot of Python people come into Go, and a lot of things make sense to them. So.
Well, if you had, say, if the uint would be default to whatever the architecture is, right?
Yeah.
Like, so if you had a uint that defaulted to uint 32, and then you had something declared as a uint, and then you did a %t on it in the print statement, would that come out as uint 32?
No, it would say that it's just a uint, but underneath it's whatever the architecture was.
But if you declared it as a uint 32, it would say.
It would say uint 32. All right. And so Go has two keywords called make and new. These are allocation primitives, and although they sound like they do the same thing, they do different things under the hood. So new, it allocates the memory, but it does not initialize it. So it does 0 values. A example of that would be, so we have a structure called sync buffer, and it has 2 fields. To be able to use that, we have to make a new copy of, or new instance of it. So we call new sync buffer, and P becomes that data type. And then another way you could also get it is by using a variable assignment. It does the same thing. Another thing the new keyword does is it returns a pointer, whereas calling it via a variable assignment, it's just straight value. And then make this similar, except it only operates on slices, maps, and channels, and it initializes the values. So in this case, we're making a slice of integers. It's going to define the first 10 values, but this slice is going to have a maximum capacity of 100 items.
How does the slice work?
A slice is a form of array. We'll get into that later. The way it works is kind of interesting. So the major difference is we want to make a slice of integers. Well, if we call it this way using the new, then it allocates a new slice structure, but it's going to be all nils, which typically that is not useful, especially when you're wanting to deal with integers. Whereas if you were to call make, then you'd get a slice of zeros, and you can work from there. Calling nil or new to get a slice is also a bit unnecessarily complex versus doing the same with a make. So calling it with this method, or using make and getting a pointer, that's not very idiomatic in Go. Typically when you do that, you want to actually get the data values, but that also is determined by the way slices work.
There's those little asterisks up beside the
Those define that it's a state that it's a pointer,
Okay.
much like in C.
Or I mean the one beside the brackets in. Does that make it a slice?
The brackets here is what determines if it's an array or a slice.
Okay.
The asterisk means it's a pointer.
Okay. Does that mean it?
The brackets will be more clear here, talking about arrays and how they work. But that just returns the memory address since it's a pointer. So P is going to have the memory address of wherever the slice exists.
Okay. I get the one the asterisk is next to the variable name, but when it's next to the type, I'm a little confused about what that does.
Because new returns a pointer, and so here you're dereferencing it. So you're taking a pointer, grabbing the memory address in the pointer, and then you're looking it up and grabbing the data value that it points to, and just taking that.
Okay.
So arrays in Go are they're useful when planning the detailed layouts of advanced memory structures. The one problem, though, is once you define an array, it cannot be resized or altered. So if you make a array of 100 integers, you're stuck with that up until the point you get rid of it and it gets destroyed by the garbage collector. And a few notes about arrays. Arrays are values, so if you assign one array to another array, instead of having an array, it copies all the values from the one and puts it into the other. So you get one large array, assuming that the first array is big enough to hold all the values. And then if you pass an array to a function, it'll receive a copy to the array, not a pointer to it.
Interesting. Is there a way to send a pointer to a function?
Yeah, you can send a pointer to an array, but working with arrays directly is not idiomatic in Go. That's only useful if you really need that level of control over the memory management. It's better to use slices.
Okay.
So that would be on the next slide. And the size of an array is part of its type. So the types like the open brace 10, close brace, and then int, and that's an array of 10 integers, or this is an array of 20 integers. And both of these are distinct types. So in an example of an array, and also something to be careful of, is the value property, the braces. They can be useful, but they can also be expensive. So in this example, we're building out an array, and we're telling it to count out. So it's going to be whatever the number of elements you stick in here is going to be. It's going to be the size, but in this case, it's going to be 3. And then we're calling a function sum on the array. And as you said, asked, this is how you would send it a address of, or a pointer.
Just with the and.
Yeah, and then up here you'd use the asterisks. And so in the sum, we're defining A as a array of 3 float 64s, and we range through that array, adding up all the values, and then we return a sum float of all the values. Now the reason this could be expensive is because if you have a large array, telling it to count, that's just CPU cycles that it's having to do. Whereas if you were to specify the size, that will cut down on the cost. Or if you were to use a slice instead, all of that's dynamic and handled under the hood.
Is it necessary in the selection parameter to specify it so size 3 type?
Since if you want this to be an array, yes. Otherwise, that will be a slice.
Okay. So if you wanted to pass it a size 4 array,
then you would change that to be a 4 instead of a 3, and then it'd be an array of 4 items.
But that's a different function definition.
Yes.
Yeah.
But if you say accept a slice,
Then you can send it whatever amount of things you want.
But it's pretty strict about what you put into your functions.
It goes with a strongly typed language. It's just the nature of the beast. But slices are wrappers around an array, so they work and look a lot like arrays. And under the hood, they actually are, but you don't have to tell it the size, and they're not constrained like arrays are. So slices can be resized at any given time, and all that happens is under the hood is if you try to expand the array, the Go runtime creates a new array that's larger and then points the slice to the new array and then just destroys the old one. So under the hood, it's all arrays, but it's all transparent to you. You don't see any of that.
Sounds like it's all geared around fast access time.
That is the point. And so, as said, slices just point to an array. It just holds the references to the underlying array. And if you take a slice and point it to another one, or so if you take a slice and you assign it to another slice, both slices point to the same array. So you're not duplicating values at that point. You just have two things pointing to the same memory address.
So it's like a pointer, or pretty much a pointer.
It works like a pointer, yeah. And if a function takes a slice argument, any changes made to that or to the elements of the slice is visible to caller, since it works just like a pointer.
But then anything that happens in the function would change the values in the array, and that would kind of get beyond the wrapper of the function, right? Well, I guess that's basically how pointers work in general.
Yeah.
I'm not used to pointers.
It all operates on the memory address, so anything that points to it sees the changes immediately.
Okay.
Now, the one thing to be aware of, though, is Go arrays and slices are one-dimensional. So there's not really a thing called a two-dimensional or a three-dimensional array, but you can create similar using a array of arrays or slice of slice concept. And to do that, it's just a matter of defining arrays like this. So you have a 3-element array and a 3-element array that's both float 64, and that should have been a 3x3 array.
That means you could not have 3, 3 inside the brackets. You have to have separate brackets.
Yeah. And the slices work the same way, so you have to have a slice and a slice of the same data type. But the slices are variable length, so it's possible that each inner slice be of a different length, whereas arrays, not really, because you're going to have to specify the size here. An example of that is, so our lines of text, that is our outer slice, and then inside it we have a slice of a byte. That's this first element is just going to contain now is the time, the second is going to be this line, and the third is going to be this. Even though they're within the same containing slice, these are different sizes, and it doesn't care, because this has its own array, this has its own array, and this has its own array.
Can you put a slice inside of an array, like you make it multi-dimensional, have one that's an array and the next one a slice?
That's what that was. That was an array of bytes. A string in this is a slice of bytes.
Oh.
Yeah. Yeah.
So each of those is a different length.
It's taking this string and then it's typecasting it to a slice of bytes.
Do you know what the typical, what it normally allocates for a string, like the length of the array?
I forget. It's similar to the same amount as C, though. Or no, not C. It's in the kilobyte size or bytes, but I don't know the exact number off the top of my head.
Actually, I think I get it.
So is a string the same as a slice of bytes?
No, a string is actually its own type, but you can typecast it to a slice of bytes.
Under the hood, it's probably an array.
It's their strings are muted, so or
Mutable.
they're mutable. So
An array is mutable. You just
Yeah.
can't change the length. So it's probably like a slice, essentially.
it probably is a slice underneath. And in Go, there's what's called maps. These are usually your like Python dictionaries or hashes or things like that. It's just a basically key value pair driven structure. The advantage of this is a key can be of any type, so you can have keys of strings or keys of an int or in floating points or a complex number. You can even have pointers or
Arrays.
arrays or
Objects that have been instantiated.
Go doesn't have objects, but it can be interfaces as long as the dynamic type supports equalities. So it just has to be able to compare this and see if it equals this.
You have to explain how it does that then,
How
without
do you
having
do that for a
class
floating
definitions.
point?
So the floating points, they support equality. You can compare. So as long as you can say if this equals or if A equals B,
Yeah.
then you can use it as a key in a map. So if you can say like 0.0001 equals whatever. Now it may not be completely accurate, but
Rarely equal.
yeah,
Right.
yeah, you get into some interesting
That's
floating
like-
point math issues, but it is possible to use them as a key.
Are there floating points directly architecture dependent, or do they implement some abstraction layer to maintain cross-platform?
It's
compatibility like Java does?
there's an abstraction layer because Go is can be cross-compiled, so that is all handled within an abstraction to make sure it all works around the board.
Are those, on the left, are those supposed to be like strings? They could be anything?
Oh, here, yeah. In this use case, I'm using strings. This would be the key, and then over here's the value. So the way it works is you define your map,
Yeah.
and then in the braces here, you specify the type
Yeah.
that the key is going to be. So in this case, we're saying string.
Yeah.
So now it knows to expect keys that are strings.
So you've got the string in, but those double quotes are necessary. They're not.
Yes, because that's a string.
I know. But I'm thinking like in Perl, for example, there
Oh.
are situations where you can omit the quotes because it's understood to be a string, depending on the context.
No, the strings are required. Or the quotes are required if it's a string.
Strings are immutable.
Ah, yeah.
Okay.
But if you were to say like this is the map of ints, then it would just be like 1, 2, 3.
Yeah, right, yeah.
Yeah.
All right.
And they have to be double quotes because single quotes mean something different in Go. So if you do wrap something around single quotes, it's actually going to convert it to a byte.
Oh. Okay.
So if you do single quote A, single quote, that's going to return the byte value of A, not actual A. So their version of single quotes is backticks.
Right. Okay.
But in this example, we have a map of time zones. So UTC, EST, CST, and then a conversion to get seconds. But this could easily be something else. So this could be int or If you're crazy, this could be runes, and then all your keys could be Unicode characters.
Why would that be crazy?
Because I'm pretty sure someone will do the table flip guy as a key. Just
Back when I was using Flash and ActionScript 3, they had this data structure called a dictionary, where your keys in an array could be an instantiated object. Like you go through and make all these, display screen clips, and you could use those as keys in your array. Use it once for a really nasty and quick-written garbage collection system that destroyed everything. But is this something that structure could do?
Can it
Well-
take another type? Can you define an object and then use it as a type?
yeah, you can define your own type, which that goes along with the interfaces because custom types are an interface. So you can do your own type.
As long as it has the equality.
Yeah, as long as it can it understands equality, then you can use it.
So like in Python, the way they would handle that is under the hood, any of these types are objects, and they have hidden methods that do things like the equality. So they'll essentially, like, if it'll cast itself to a string or cast itself to an integer to test equality.
Okay.
So if you implemented that, there's probably a way to do that. If you had that implemented in your object, but you have to have that hidden method implemented.
I think with ActionScript, and don't quote me on this one, every object that you instantiated had a identification number associated with it. So it would just go in to see whether or not the object that it was pointing to as its key was the same object that you were then trying
But
to
see,
reference.
that's then in that case, in this case, that would just be using a pointer essentially, like because you would be
You're probably right.
because that's an instance. You're checking to see is it the type of this object. In other words, if I write this class,
Is it the same instance as I had set this key?
it's saying is this the same instance. So
Right.
it wasn't testing for types. It was saying is this exactly the same object in memory.
Mhm.
So that's more about address than anything else. So
Yeah.
you could do that. The easier way, lower performance problem ways to do it than actually using the object. You could just grab the pointer and use that as a key. You could because you can pull the pointer as a UIT, or what is the pointer returned as typically? It's just a pointer.
yeah.
But, yeah. But you just use the pointer.
Yeah, it sounds like I'm going about it the long way.
Well, Flash was.
Yeah, and pointers are allowed as keys, so. And then, so to assign and fetch values on a map, syntactically, it works the same as an array or a slice, except the index doesn't have to be an integer, since they can be various. So you'd have your key variable and then the key there. Or if you were assigning the equals and then your value on this side. Interesting thing to note is an attempt to fetch a map value that's non-existent within the map will return a 0 instead of an error.
Huh. And then do they not have a null type of any sort?
They have a nil, but the maps don't return it for a interesting reason. There's another way to catch if it was truly 0 or if it's 0 because it didn't exist. And the way you do that is by what's called comma okay. So for that, you define a second variable that's a Boolean, commonly just seen
So it's
okay.
set okay is true. If
Yeah, so if it existed, then okay would be true. If okay was false, then you got it 0 because it didn't exist.
Kind of fucking bullshit. Why'd they do that? I mean, that seems because you wanted to be able to store a null and I mean, I get
because keys can be of different types and not everything has a nil. So
And
number
you could
types
have-
don't do nils.
I see.
Yeah. So that was their workaround for it.
Interesting. So you don't have to. So if you're using the map, you don't have to implement something to handle a nil. If all you're dealing with is numbers, you just
Check
look
to
at
see
the
if okay
key
is true.
I get you.
I've read some horrible
The interesting thing there is it's returning multiple values.
Yeah, that is supported in Go. You can have multiple
I think
returns.
that's a Python thing too.
I thought you guys had to do it in an arrays.
Tuple unpacking.
Yeah.
It does it, but-
Tuple unpacking, but this is actual multiple returns, not a workaround or
Return with
anything.
multiple
Yeah.
values inside it.
So they can be varying types.
That syntax works in Python essentially.
Yeah, it's just you'd have to pack it as a tuple before you return it.
Yeah. But the syntax is the same. So
Yeah.
it really doesn't matter.
Which is why a lot of Python programmers are picking up Go and liking it, because syntactically it feels a lot like Python. And then there's another interesting character, so a blank identifier, an underscore, and that is, I know this is going to return multiple things, but ignore this value here. So that'd be useful. So let's say you didn't care what the time zone returned when you tried to fetch a key. You just wanted to make sure it was there. So you can ignore the actual data and just get the Boolean value to see if it's going to exist.
I guess rid of all those is set things you have to do in PHP.
Yeah, you just call it and see if it errored.
But what if you made that return type, go directly or inside of an if statement? Which one would be the one that the if would check against? The first one or the second one? Or is there a way to tell it which one you want the if to look at?
So you want to wrap that into an if?
Yeah, like if I just wrap that colon equals time zone inside of an if statement.
The way you do that is kind of interesting. And let's see if I can.
I know I've written long bodies of ifs that did very strange things based on whether things are defined or not.
Yeah, let me make it pretty.
So kind of how ifs react as a.
So we will make this return a. Now we'll just do it 1 and a. So this function is actually going to return an int and an error type.
So nil is of type error.
Type error implements nil. So let's get rid of this line here. So if, and then num and error. Error equals. Nil is a built-in. It's not actually a singleton. Go isn't object-oriented.
So, but that's what I'm asking. Are you checking? Wait, you said Go isn't object?
It's not. It's a hybrid. So it has part functional, it has part object-oriented, and it has part procedural.
So what are you? What I'm guessing what I'm asking is the double equals. Are you checking object equivalency?
Yeah, that's so.
Because if you're checking object equivalency, that indicates that nil is indeed a singleton.
It works like a singleton, but so here, since error implements nil as a value,
Right.
so it can be nil, or another way to do it is if you want to see if it didn't error, you would say not nil.
Right. But my question is, when it says nil there.
But type of error understands nil. That's, I don't know a better way to phrase that.
Well, so in Python, since I keep going back. So null always has the same memory address. It's instantiated when you start the Python interpreter, right? So to check for it, it's very simple because you're just checking to see if it's exactly.
But null is also an object in Python, whereas it's a keyword.
So it's probably equivalent functionality in that you're not having to go look up. Exactly.
Yeah, you're not having to look up a memory address or anything.
Yeah. Okay.
Right, when you use an if, you don't have to wrap the cases
No,
and anything.
that's one thing that they hated a lot of C. So and one thing that I mentioned in the Intro to Go class is Go was Rob Pike and Kim Thompson's ability to go back and fix everything they did wrong in C. So that was one of the things.
It's like on the 10th day, God decided to redo the birds.
Yes. But it erred because I'm not using num.
Right.
Yeah, we'll just ignore that.
Well, thank you, program.
Yeah.
So that's actually something I don't
So
think Python can do.
Yeah.
Assignments in.
Yeah, the order of operations kind of weird here. So what happens is this gets executed before the if is even considered. So it's running these, assigning these values, and then after the semicolon is when the if actually kicks in.
Gotcha.
Now, what happens when the if is true?
Ooh.
Yeah, it creates a. Oh shoot! I'm kind of losing my train of thought. Yeah, if it just started after the semicolon, what happens if it's true? Because it might help me learn a little bit more about the fundamentals of the language.
Well, in this case, it is true because I'm returning a nil for the type error,
Okay.
which is the second return value. So here, error is going to be assigned
Just
as
run
nil.
what's inside those
Yeah.
curly braces.
Okay.
Error, you could get error from any assignment statement if you specify it. Or
If the type does it. So if it's a number type, you will never get a nil. If you see a nil in a number type, then something is wrong within the universe.
Okay.
But if it's like a error implements it, the slices and arrays implement it. So if it's an empty slice or an empty array, it will be of type. The value will be nil.
Okay.
And interfaces, they implement nil.
Yeah.
But other than that, it's going to be your main things to check for is nil, 0, and empty string.
Well, you're just trying to chart what happens after the if is true. You're checking to see whether or not nil is the same as error.
Yeah, this is the if statement. The main if statement is here.
The main if statement?
So ignore this if here. This runs first, and then it goes if error equals nil.
Okay. Then execute what's inside the bracket.
Yeah, so this is the same as saying here. That is the same as saying this.
Okay.
It's just way to do the assignment and comparison on one line.
Sure about that. And semicolons aren't mandatory?
No, unless you're doing something like that, because the compiler will go in and eject semicolons.
Okay.
So unless you're running, have two lines of code on the same actual line, then you don't have to worry about ever typing a semicolon.
Okay. Actually,
Another thing they borrowed from Python.
this is really close to what I was asking earlier. But to really get at the heart of that question, if you were to erase the semicolon, colon, space, ERR, space, semicolon, equals, and just say if something, parentheses, parentheses, what would it do? Would it check the first or the second variable that something would return? Or is that even something it would consider doing?
Repeat that again?
If you took out everything from the underscore all the way up to the right before something and just said if something,
So if I were to take all that out,
or no, it took out too much. Leave the something.
If that
Call
function
that
is
something
declared.
else.
Oh.
Right, yeah. If you just got rid of all of that and basically if solely off of that function call,
oh, that's even easier then.
because doing two different things at the same time. Would the if go with one, the other, or both, or?
What does that do?
That negates it, and then now, so if something returns true, so
But
it's
with
going to
the-
have
so
a
it
1
will-
and nil. So
Oh, it is going to return both values. It's going to have a. Okay.
yeah, it's going to look at that and go, yeah, that's true.
So is nil truthy then?
Or is it going to end them?
It's not going to end them, but it's going to see the 1, and it's going. So the end's going to be 1 instead of the 0. So that's true, and the error type is going to be nil.
Which is gonna
So
be-
that's going to
Run it.
be true.
Run it. Right now. Run it. Run it.
Nil's going to be true, or Nil's seen it being true.
Oh, single value context.
It did not like that.
Yeah,
So it doesn't have the capability of handling a multiple value from that.
not like that.
Could you return more than one comma?
Yeah.
Yeah, you can.
Oh, you can. Yeah, you can return 12.
String
Of
float.
course, that seems like it's kind of breaking things because that second value is supposed to be whether
No,
the thing exists or not.
No.
And not?
no.
That's only for the map type.
Yeah,
Yeah.
the map
I thought it was
does that, and then
No, he's just showing you the under the hood implementation
Yeah.
of what's going on.
Okay.
yeah. So map is the only time that the second value is going to be whether it exists, and if you're doing a range operation, the first variable is going to be your key. The second is going to be your value. But those are really the only times where the orders matter.
Okay.
But if you're doing something like calling a function, the function may return like 8 different things of multiple types, and it
Just whatever you've set up for it.
Yeah.
It just so happens that map is set up to return as it's
as the value, and then return a boolean if it exists or not.
Okay. Would arrays and slices do that too, or just maps?
Just maps.
All right.
And then, so to continue on, going back to the maps, to remove a key from a map, you just call the delete function with the arguments of the map and the key to be removed, and then it'll delete it. This is safe to do even if the key does not exist within the map. It'll just silently ignore or silently error and just move on, since there's nothing for it to operate on. And the way constants work in Go is a bit different. So constants are created at compile time, even if it's just local to a function or a method. And because of this, there's a limitation. They can only be number types, characters or runes, strings or booleans. And that's because it can't do custom types because those don't exist at compile time. And then another limitation is the constant expression has to be evaluable by the compiler. So, for instance, you can call this but you can't make a call to math sin then pi divided by 4. Because the math sin and math pi don't exist at compile time. Those exist during runtime. But you can have enumerated constants. So you use the iota enumerator and it can be repeated within the expressions implicitly. So you can build sets of intricate values. So in this case, we're building out file size. So we have our byte size, which is a float 64. We're going to ignore the first value, so we're assigning it to the blank identifier. But then we're going to have kilobytes and our expression. So once that gets ran, the rest of these are going to have that same. So it's the same as basically taking this line and copying, pasting it for the megabyte, the gigabyte, the terabyte, petabyte. This is all understood to be the same as that at that point. So less typing you have to do.
Okay. Is that a standard programming concept, or because I've never seen that before, or is that something that Go does that's special and unique?
I haven't seen any other language do it this way. I don't know if you've run across.
I don't even sure what it.
No, I don't think so.
Huh. So it's saying that the constant KB is going to be a byte size and it is equal to 1. Sure, it is. It's a byte shift, right?
Yeah.
Of 10 times whatever iota is. Is iota getting incremented every single step?
Yeah.
What's incrementing it?
Itself. Iota is a numerator. So every time you call it, it's just a new one.
Okay, and that's a construct of the language?
You pretty much, yeah.
Huh, okay. Why did you assign underscore that way?
That would be 0.
Okay, so it skips over 0 and starts with 1.
Yeah.
Okay.
It's kind of like a list comprehension or array comprehension in the compile
Yeah.
point. That compile,
Yeah.
which is kind of interesting.
And you reset it by setting it equal to 0?
I'm sure you could.
Alright.
I haven't tried it.
Oh, I'm going to get myself in so much trouble with this for loops.
All right. And so anyone who's done C work in the past will be familiar with this. Structures. It's a collection of exported or unexported fields. It's useful for creating complex data types. So an example here, we're building out a type of location that's a structure. So to have a location, we need a latitude, which is a float 64, and a longitude, which is of the same type. In this example, both our types and its fields are exported, so it's accessible to other packages. So everything in Go is a package. So a binary is a package main, and then all libraries is a package of that library. So if this was existing in a library, then any program or any other package that pulls us in can now access this structure and its fields.
Okay.
So basically a private-public type mechanism. And then using structures, it's the fields are accessed by the structure dot and then the field name. In this case, we are defining our location L, and we're assigning the latitude and longitude of that of Chattanooga, Tennessee. And then we're going to call this format method that's on the location structure that will print out the floating point number, degree sign in, and floating point number, degree sign west with those values. Now, because this method is attached to this type, we don't have to pass it anything. The second that method gets called, it knows what values are in these fields. So it can immediately access them. And so we get this little with our geolocation. Another way you can do it is oh, I don't know why those are the same. So there's two ways you can define these, and I'll just copy and paste this into another Go bin since that got messed up. So that was the longhand way of defining a type, but there's also a shorthand. So instead of having these on separate lines, we can say L equals, and then our location, and we have to use curly brace, and you name the fields when you're assigning the values. So the lat is the 35 point, and our long and then that's just another way you can define it. So you can break them out, or you can do it all at once and define and initialize in one go.
You're defining the structure location in that statement, man,
Yeah. So
as well as populating
yeah. So this is making L of type location and assigning values to the
it.
fields.
Right, and location is only defined here, it's not defined somewhere else, right?
Since the name of the location is starts with an uppercase L, it's exported, so it's public.
It's public, but it's created there.
Yeah, it's created here.
Okay.
And as we saw in the last examples, methods, the format method from the example, since it was defined on the location type, it had access to the fields. And methods can be defined on any named type except for pointers and interfaces. And so that means the receiver doesn't have to be a structure. So this could be, instead of being location, that could have been like a int or a float, and then any integer or any float could then be call this format method. But in our case, we just defined it on that structure. And then interfaces. Interfaces in Go provides a way to specify if something can do this, then it can be used here. And it's commonplace in Go to have interfaces with only one or two methods. A example of that is within the IO package, the writer and the reader. They implement a method called writer and one that reader. And what that does is it will either write to a buffer or read from a buffer, or a file, or stdio out or std in. So it's just a way of working with different things. And a type can implement multiple interfaces even. So for instance, a collection can be sorted in routines. So package sort implements a sort.interface, and you can use that, implements the methods it contains, which is a len, less, a bool, and a swap. The only one that you don't have to define yourself to meet this requirement is bool, since it's a unexported. And then you can also have a custom formatter, but that's also not a requirement. So in this example, we're basically re-implementing the sort mechanism in Go. So we have a type of sequence, which is a slice of integers, a method attached to it for length, a method attached to it to find the lesser value, or to check to see if it's a lesser value anyways, and a method to swap two values. And then we also define a method called string, which is our formatter. So we have
It returns a string.
yeah, it's going to returns a string. So it takes a sequence of numbers and then it actually will spit it out as a string.
Does it take a sequence of numbers or operates within a sequence of numbers?
Since the sequence is a slice of ints, it's going to contain numbers.
Right. But does that method live inside of sequence or outside of sequence? I might have been misunderstanding something.
The method is defined on sequence.
Okay.
So it's not necessarily within, but only sequence can call it.
Okay. So it wouldn't be inside of the class definition of sequence, but it would be inside of the instance S of sequence. Or am I kind of blowing this up?
That's one way you can phrase it, but using class and objects terminology is kind of bad since it's not object oriented and doesn't have a true concept of objects and classes. So
Okay. Maybe let that one go for a little while. Sorry.
So basically what we have here is now anything that is of type sequence can call our string method, and it will return a string value of whatever was in that slice. And then they can also make use of our custom length check, our less check, and our swap. So they can use our implementations rather than using the built-ins, or you can make your own implementation of something. You just have to make sure that you implement the fields that the interface requires, or the methods it requires. And then in the last example, the string method, it was also duplicating the work of the sprint. So you can do type conversions within that. So you don't have to necessarily do a type conversion and assign it to a variable. You can use it as a pass-through. So in this case, we had a slice of ints that we have a slice of ints, and then we take the sort s is a string. Since it's a string, what we're doing is we're taking our slice and then we're going to spit out a string. So it's converting from integers into, or a slice of integers into a single string. It's phrasing that is a bit weird. And then you can also use a switch statement to determine the type. So in some cases, like implementing the JSON or XML encoding, there's some cases where you'll get back a type that you may not know any of the fields for, because in that case you don't know what data types you may be dealing with. You can use a switch statement to walk through that and determine types. And that's called a type switch. And the way that works is you take your value and call dots and then type in parentheses, and then it can walk through. So if it's a Boolean, it'll trip, or if it's an int, it'll trip. In that way you can discern the types of something that was dynamically created.
Okay. Does it need breaks or not?
No, Go doesn't do switches in Go doesn't do fall throughs. So once a case is met, then it just stops there, or it breaks out at that point.
So what happens when something does fall through?
The default.
Ah,
Does fall through? Or
No, it will hit default.
okay, so that's
So if none of these cases match, then default gets called.
gotcha.
yeah. I've never really had a good reason to use a fall through anyway. They've always been kind of awkward.
Well, it's useful. So if you say you had multiple cases that you want to operate the same way, you can say case A or in case B, and then give it something.
All right.
That's the only time fall through really is handy, because if A triggers, but you want it to do the same as B, then you let it pass or fall through to B.
Okay. I was thinking of kind of having it split between the two of them. So the first part of the switch statement is done if it matches A and B, and then oh, never mind. How do you do that? Is there a way to specify more than one cases for a statement that you're going to execute?
Not in Go, since it doesn't do a fall through.
So you have to re-type it out each time?
Yeah.
Or put it in a function?
And that's the end of the slides. Any questions or anything further explain, confuse?
That's pretty confusing.
I think I've asked a couple already. Trying to exchange one level of confusion for another level of confusion the whole time. But some of it makes a lot of sense and seems pretty...
So is it a compiled language? I mean,
Yes, Go is a compiled language, but it compiles quickly. So what would take like a C compiler minutes to do, Go can spit out in seconds, which is why they're able to be able to have the online compiling like they do at that site. So if you the play.golang,
Yeah.
anything you run through there, it gets compiled and then ran.
So the compiler is available for lots of platforms?
It's it's right now it's available for Windows, Mac, Linux, FreeBSD, and then once 1.3 hits, they're actually adding more. So let's see.
It just creates, a native executable for
Yeah.
whatever platform.
And it can cross-compile as well. So I can be on my 64-bit Macintosh here and compile for a Linux running an ARM processor.
Oh, really? That's kind of cool.
Let's see here. Yeah, so right now it's FreeBSD 8 or later, and the architectures is 64, 32-bit, and ARM. Linux, which is has the same. Mac, which is only the 64 and 32-bit, and XP 64 and 32-bit. And I believe, hopefully they updated the documentations for TIP.
What's that about Sigwin?
Oh, no need for Segwin or MSSys
Oh, yeah.
because it uses Ming
This is
GW
straight-
GCC.
Yeah, okay.
Okay, they do not have that. But in 1.3, they're actually adding support for more systems. I believe Plan 9 is on there, even though it's based off Plan 9. I forget the others. It was on the mailing list. But they're also right now the compiler is also currently written in C, and they're in the process of rewriting it, so the compiler is written in Go. So you need Go to build Go.
So that's the feel of a new language getting started, but you've really thrown your whole self into it.
Well, all the
It kind of excites you.
Google threw all their weight into it. So
Yeah, they
it's
did.
Kind of, it's a lot of impetus.
yeah, it's Google is dogfooding it. So if you download any files that come from dl.google.com, that's a Go server. The Maps backend is a Go server, and YouTube is using it in the backend as well.
One of the problems it actually solves for Google, believe it or not, is not the code. The code is, I'd say Google probably has
It fixes a lot of their
larger-
scaling
the
issues.
well, it's deployment.
Yeah.
So you have an executable. That's your web server, and you push it out to whatever.
Yeah.
know,
I actually
cluster
have
you
an
run.
example of that.
And I think you were just on a pretty extensive list of packages, I guess, too. Huh?
Yeah. So this is all the system built-in libraries. So it's a fairly extensive list, and there's a lot of people who've built more.
Hey, scroll back up a little bit. A little more. There, right there. Plan 9. Objects out. That's cool.
Yep.
But it
I
seems
wish I
everyone's...
had plenty of time.
Like even the compile toolchain is a package, so you have all the documentation there. So if you want to know how the build process works, here's your documentation for it.
object-oriented is kind of becoming the buzzword of the day.
But it's not.
Yeah, how are they going to circumvent that? Or think they're going to rebrand or change everybody's minds?
No, because object-oriented is just a paradigm.
Mm-hmm.
And the Go actually borrows a bit from procedural paradigm, borrows a bit from object-oriented paradigm, and borrows a bit from the functional paradigm. So it's a hybrid of the three.
So what does it borrow? Because I haven't really seen any object-oriented stuff here except structs, I guess, or what they're considered.
The way they treat structs is probably the closest they've gotten to from the object-oriented side. And then the way...
And you were attaching... So you were attaching...
You can attach a method to a type. Well, that's like defining a class to an object or something. Or
that's just defining a method on an object.
Yeah.
But what... if you showed where you export a struct, or you export stuff,
Yeah.
You showed where you export a struct. In that file where you're exporting that struct, you can also define methods on that struct that would then get imported you would then import with the struct.
Yeah.
Okay, so that's kind of like a class definition.
Yeah, there's some functionality there, yeah. That works a little bit the same way.
A lot. So I don't do a huge amount of web stuff. I mean, I do some, but a lot of what I do, the object-oriented paradigm makes a lot of sense for what I do because I'm dealing with objects, which is what it was. So it would make me uncomfortable not to have that for certain things. For web, I kind of understand. In a lot of cases, it's a bit over. People get a little insane. I mean, good job, developers, right?
PHP. I tend to do a lot of procedural, kind of hashed into an object-oriented approach sort of way.
Exactly.
Like if I'm
a convenient way to manage it, if you want testability, then okay, you're going to need objects.
to make it a little easier. Like
Easier. So it's easier for you to instantiate an object in your test framework than to keep your test framework updated to run all your functionality or whatever.
Yeah.
Gotcha.
Yeah, so
very grateful when somebody before me used good documented object-oriented methods, and my code always looks like this sequential hybrid that branches off of it in all sorts of directions.
Go enforces good documentation.
It does?
Because the go.doc command, it generates the documentation by reading in your source files. So everything you see here came from the source files for Go build.
Maybe you talk about how you organize your resources when you're making a Go project would be a great thing for the future.
Yeah, I can do that as a talk. But yeah, so like here, so the context struct, it grabs these as its documentation. So because it's exported, it requires this line up here that gives just a quick sentence or two explanation of it. And then since these are exported, you have to specify what they are, and then implementation details. And the Go lint program actually will check for these and complain at you because you don't have documentation done.
Okay. So you basically learned Go instead of C? You do very little C?
I know a little bit of C. I took a class on it.
Yeah, but you started with Go, and Kim Thompson would like that. That's the way it should have been.
Yeah. And then also to go back to the is Go compiled question, like here's my personal website. It's built in Go. The website down to the web server is Go. So like here's the source files for it. So if I do go build dot, and then pulling down some.
You had some
that binary there is now my web server. So instead of running Apache or Nginx or anything like that, I just run that and my web server is up and running.
And everything's in there.
Yeah.
So how big is that?
Well, your resources aren't in there, right?
No, the static stuff's not.
Right.
But 11 megs.
Okay. What you recommended a couple of books specifically. I didn't get those yet, but on Go.
Yeah, actually have some digital copies of it. let's see. Let's stop this.